Okay, you guys, now let's get started with chapter 5. What we're going to be doing is we're still going to be simplifying radicals, but we're going to prove and use the Pythagorean theorem. We're also going to use Pythagorean theorem to derive the distance formula, and we're going to identify Pythagorean triples. Now for your warm-up today, kind of went a little bit old school. Let's see how well you remember prime factorization, okay? Listing the factors of 66. I'm gonna go old school again because I used to teach 5th grade, but this is how we taught it then. 1 times 66, 2 times 33, 3 times 22, and 6 times 11. Now to write the prime factorization of 66, that's where you do a factor tree. You're breaking the number down to where you have nothing but prime numbers, okay? So for 66, I will do 6 times 11, okay? 11 is a prime number, so I stop there. 6 is not, so I need to break that down into 2 times 3. 2 is a prime number, 3 is a prime number, and now bring this down, 11. So this is your prime factorization for 66. Now, let's take a look at the factors of 75. Gonna make a T-chart again. 1 times 75, 3 times 25, and 5 times 15. Now let's do the prime factorization. That I would use a factor tree for 75. I'm going to go with 3 and 25. You could use any of those. It's not 1 times 75, but you could use the other two. But I'm going to go ahead and do this one. 3 is a prime number, so I stop there. 25 is not, so I break it down to 5 times 5. 5 is a prime number. Bring this one down times 3, and 3 times 5 is the prime factorization for 75. Now, we kind of get into the Pythagorean theorem, except this time what we're going to branch out into is we are going to see if they give us all three sides, is that going to be a right triangle? Notice it does not have the right angle in the corner, so don't panic, because if you paid attention at the last lesson, I told you whatever side is largest is going to be your hypotenuse, okay? So that one will always work out that way. Don't panic on that part. So it doesn't matter which one of these come first, but you're going to use the Pythagorean theorem to see, is that a true statement? A squared plus b squared equals c squared. Is that a true statement? If it is, then this is in fact a right triangle. So I'm just going to do this one first. 6 squared plus 7 squared equals 8 squared. 36 plus 49 equals 64. 36 plus 49 equals 85. 85 does not equal 64. Be sure to use the not equal symbol, okay? So is this a right triangle? Your answer is no, it is not. Now, if you were to come down here and this equals this, then your answer would be yes, it is a right triangle. But they have to equal. It has to make a true statement in order for it to be a right triangle. Now, example 2 wants us to find the length of the hypotenuse. So we're going to jump right in. This is a continuation of what we did yesterday. I do not know the hypotenuse. Remember where to find that. So I'm going to do 8 squared plus 15 squared equals c squared. 64 plus 15 squared is 225 equals c squared. 64 plus 225 is 289 equals c squared. Now remember, I don't want c squared, I want c, so I'm going to find the square root of 289. So I'd go to my calculator, square root 289. If I get an even number there, whole number, then I'm good to go. If I don't, then I have to go to y equals, and I'll be putting my answer in radical form, okay? But 289 is a perfect square because my answer is C. Okay, example 3. Find the missing side of the right triangle below. This obviously is my hypotenuse, okay? So I'm just going to let this be A squared plus 7 squared equals 14 squared. A squared plus 49 equals 14 squared is 196. Subtract 49 so that you can get that A by itself. And you have A squared equals 147 square root. 147 is not a perfect square, so I now have to go to y equals 147 divided by x, and I need to look up the factors. And when I do, I can see the largest perfect square, 49 times 3 equals 147. I can take that 49 out of there as 7 square root 3. So A equals 7 square root 3. Okay, example number 4. What is the diagonal of a rectangle with sides 10 and 16? So here they've shown you do have a rectangle. You have 10 and 16. They're wanting to know the diagonal. So if you think about what this picture is, directly across from here, that's your hypotenuse. Okay, that's going to be your C. So, they have a D there. If it doesn't confuse you, I'm going to go ahead and put D there. But let me just put C because I don't want anybody to get confused. So this is what I'm looking for is my hypotenuse. So 16 squared plus 10 squared equals C squared, which is really D, okay? 16 squared is 256 plus 100 equals C squared. 256 plus 100 is 356 equals C squared. Then I have to find the square root because I'm wanting to know what is the length of that. And as I go through my list, when I look up the factors of 356, surprisingly, the biggest perfect square I see is 4 times 89, okay? Square root of 4 is 2, so that comes out of the sign. 89 is very large, but all you have to do, if you see that, just go back to your calculator, put 89 divided by x, and check your factors of 89, just if you want to be sure, because it is a rather large number to still be under that radical sign, but just make sure, okay? And then you wind up getting C equals 2 square root 89, so that would be the length of that diameter right there, that diagonal right there. Okay, let's talk about a Pythagorean triple. It says, in example 7, the diagonals of the triangle were 8, 15, and 7. This combination of numbers is called a Pythagorean triple. It's a set of 3 whole numbers that makes the Pythagorean theorem true. So they've shown us some examples, 3, 4, and 5, 5, 12, and 13, 7, 24, 25. These are actually sets of numbers that hold true. Now, if you're ever asked the question, like here we go, is 20, 21, 29 a Pythagorean triple? Well, first of all, the largest number is 29, okay? So that's going to be my C. Doesn't matter which one of these comes first, okay? But now you're going to see, does it make a true statement? 20 squared plus 21 squared equals 29 squared. 20 squared is 400 plus 21 squared is 441 equals 29 squared is 841. 400 plus 441 is 841. That does equal 841. So yes, this is a Pythagorean triple. Now, is it very much like that question we did earlier where we're trying to decide, is that a right triangle? Absolutely. So finding out if it's a right triangle and finding out if it's a Pythagorean triple, you do the exact same thing. The largest side is always your hypotenuse. Plug in for the other two sides, and if it comes out to be a true statement, yes, it is a right triangle, or yes, it is a Pythagorean triple. If it comes out no, then no, it's not. Okay, last thing we're going to talk about here, at least as far as this part goes, is it says one way to use the Pythagorean theorem is to find the height of an isosceles triangle. Okay, now it's been a while since we talked about isosceles, okay, but if you have an isosceles triangle, remember these two sides are congruent to each other, okay, then you have your base. Remember I told you isosceles is a lot like a Christmas tree. These two sides are congruent, okay, and then it has a base, and they're saying you can find the height of the isosceles triangle. Now, some of you might be saying, why? How can I do that? Well, if you look at half of it, okay, you create a right triangle, okay, which means you would be able to find any of these three sides by using Pythagorean theorem because it creates a right triangle. Now, one thing I want to caution you, though, is if you have the distance of this whole base, remember this would be half of it, and this would be half of it. Okay, that's going to be split. So just think about that when you're setting it up. Don't let that trip you up, okay? All right, so let's see what we have here. Example 6 says, what is the height of the isosceles triangle? So basically, you have the height coming down here, okay? This is 9, okay? So that's going to be my hypotenuse. Remember, it's directly across, so this is going to be my C. They're wanting to know this. I'm going to let that be A. So that means this is B. But notice the whole base is 14. That means this side is 7, and my B is 7, not 14, because these two create two congruent sides here, okay? So what I'm looking at for my right triangle is my hypotenuse is 9, and B is 7. So I'm going to be looking for A. So A squared plus B squared equals C squared. A squared, I don't know, plus 7 squared equals 9 squared. A squared plus 49 equals 81 squared. Now here, I've got to subtract my 49. Oops. Sorry about that. Just saw what I did. All right. So that leaves me with A squared equals 32. Okay. I will need to find the square root of that. So I know already that 32 is not a perfect square. So I'm going to have to look up the factors. Okay. I know that I can break down 32 into 16, square root of 16 times square root of 2. And square root of 16 is 4. So the 4 comes out of the sign, and I still have square root 2. So that means A equals 4 square root 2. Or, technically, the height of that isosceles triangle is 4 square root 2. Now, another application that you can use with Pythagorean theorem is the distance formula. That is so that you can solve and find your hypotenuse, because technically this is what they're looking at, okay, just so you know. If you were to connect these here and here, you basically have a right triangle, okay? So that would be your hypotenuse right there, okay? So your distance formula, and we have done this numerous times this year, so not that you would have it memorized, but my goal is that you'll get all of these questions correct. The distance formula is the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now remember, you can enter that whole thing in your calculator, so just be careful. Just don't rush, and the calculator will do the work for you. Okay, so on this last example, find the distance between 1, 5 and 5, 2. Okay, this is going to be my x1 and my y1. This would be my x2 and my y2. Yes, I would really appreciate it if you would label. Okay, because then all you have to do is plug it in. And I know I'm old-fashioned, but I like to go ahead and set it all up. And then all I have to do is plug in the numbers, okay? I have x2 minus x1, so that would be 5 minus 1. And then plus y2 minus y1 would be 2 minus 5. See how easy that is when you already have it written out? Okay, so now plug it in. Be careful, don't forget the square, don't forget the plus, and enter that into the calculator. And when you do, you will get D equals 5. Really easy, that part right there. Especially because we've already done that. I believe this is the 4th time we've talked about distance formula. So hopefully by now you're old pros at it. All right, that concludes our lesson.